Now I will talk about Part 3, Apoptosis Imaging. Apoptosis refers to the spontaneous and ordinary cell death controlled by genes in order to maintain the stability of internal environment. Apoptosis is different from necrosis. Apoptosis is not a passive process, but an active process. It involves the activation, expression, and regulation of a series of genes. It is not a phenomenon of self-injury under pathological condition, but a death process actively striving for the better adaptation to the living environment. Cell death where apoptosis and necrosis pathway is known to play an important role in tissue homeostasis that is associated with several diseases and response to therapy. The degree of both apoptosis and necrosis can elucidate the mechanisms of the cell death and provide valuable information for evaluating the therapeutic efficiency. The alteration of direct or indirect biomarker for tumor cell death resulting from treatment have been identified according to the series of biochemical and molecular events. The process may start from signaling and then amplification of signaling, activation of caspase, and form the DNA fragmentation. A defective apoptosis may exist in cancer, autoimmune disease, viral infection, and hyperactive apoptosis may exist in AIDS, neurodegenerative disease, ischemia, stroke. Cell membrane alteration in living cells, phosphatidylserine, we call it PS, is located on the inner side of the cell membrane. But in early apoptotic cells, PS tends from the inner side of the cell membrane to the surface of the cell membrane and exposed to the extracellular environment. Annexin 5 is a calcium 2 positive dependent phospholipid binding protein. Annexin 5 can bind to PS with high affinity. It can bind to the cell membrane of early apoptosis through phosphatidylserine exposed on the outside of the cell. And we can use the tetrahydrobiopterin labeled annexin 5. And this is a high affinity molecule for PS, which is expressed on the cell surface in the terminal stage apoptosis, like this picture, normal cell on the left side and apoptosis cell on the right. We use tetrahydrobiopterin labeled annexin 5 to target PS on the apoptotic cell surface. And this is apoptosis imaging pictures. And different time, we injected normal saline 1 hour and 24 hours, or we treat the mouse bearing the tumor, use anti-cancer drugs, cyclophosphamide 1 hour and 24 hours. You can see after the drug treatment, the tumor apoptosis serious. This picture shows in vivo detection of PS expression during programmed cell death. The left part is the immunohistochemistry chemistry staining result, shows the positive staining, and the right shows the 3 groups. First group is control group, second is 1 hour imaging, and the right part is 2 hours imaging. You can see the result. 2 hours imaging shows the tumor clear than others. And this also the picture shows allograft rejection. That time apoptosis heavier than syngeneic model. A detection of apoptosis in cardiac tumor. Tetratherm 99M labeled annexin 5. This is a high affinity molecule for PS, which expressed on the surface of the terminal stage of apoptosis. You can see this picture. Left one is ultrasound imaging, and the middle is nuclear medicine radioimmunoimaging. You can see this within this cardiac tumor, apoptosis happens, and the right is immunochemistry staining. And recently, some new radiotracers imaging apoptosis-related molecules were discovered. Proposed mechanism for the active probe F18-1 under the environment of apoptosis tumor cells. In the therapy-responsive cells, increased cell membrane permeability and extensive activation of caspase 7-3 in progression to the cell death permit uptake of the probe. The cell uptake of F18-1 in DOX induced apoptotic HeLa cells and in xenotumor model mice. This is a carbon-11 labeled annexin 5 imaging to evaluate DOX. This anti-cancer drug efficiency for time compared with F18 labeled FDG. The result showed there is apoptosis after drug therapy. So, okay, that's all for this part.